Now we're going to look at the concept, or the process of eliminating the parameter from polynomial, exponential, and logarithmic equations. So for polynomial, exponential, and logarithmic equations expressed as two parametric equations, we can choose the equation that's the most easily manipulated and solve for t, and we can substitute the resulting expression for t into the second equation. This gives an equation in just x and y, so that eliminates the extra parameter, which is t. So let's take a look at this first one here. We have x of t is t squared plus 1, and y of t is 2 plus t. So I think the easier one to solve for is this y one. So we could take our x of t equals t squared plus 1, and take this y, I'm going to call it y equals 2 plus t. If I solve for t, I'm subtracting 2 from both sides. So y minus 2 equals t. So I take this equivalency for t, and I put it in place of that one. So it'd be x, I'm going to drop the t now, x equals y minus 2 squared plus 1. And we'd have x equals, if I expand that, let me think, maybe I won't expand it. Maybe I will solve for y, I'll subtract 1 from both sides. I have x minus 1 equals y minus 2 squared. Then I'll take the square root of both sides. So the square root of x minus 1 equals y minus 2. I guess I could say plus or minus. And we can add 2 to both sides, and we'd have y equals 2 plus or minus the square root of x minus 1. But I'll be honest, I'm not real satisfied with that, so let me go back a little bit. I'm going to go back to here. I don't like the plus or minus part. And I think we're going to see something when we finish this, something interesting about it. So I want to note that what we had here, this is a function and this is a function here. But let's go the other way with this. What if I expanded this y minus 2 squared like I almost did initially? So x equals y squared minus 4y plus 4 plus 1. So x equals y squared minus 4y plus 5. Now what is that graph going to be? That is a parabola on its side that opens to the right. So roughly speaking, it looks something like this. Now what I want to point out about this, the graph of this x equals y squared minus 4y plus 5, that is not a function. However, the original two equations were. Okay, let's try another one. This is the exponential. Eliminate the parameter and write as a Cartesian equation. So x of t equals e to the negative t, and y of t equals 3e to the t. So if we look at this, x equals e to the negative t, that's like saying x equals 1 over e to the t. And we could, I don't know how you want to do this. I mean, we can just cross multiply, or if we multiply both sides by e to the t, I'll say it that way. Then you would have x times e to the t equals 1. And then if you're solving for e to the t, and why am I choosing e to the t? Well, that's in this one. That's what I want to make it equal to. E to the t equals 1 over x. So I have this y equals 3 e to the t. So I'm going to take this and put it in place of the e to the t. So it'll be y equals 3 times 1 over x, or y equals 3 over x. That's it. Okay, let's try another one. So here we have x of t equals square root of t plus 2, and y of t equals log of t. So I think the easier one to solve for is here. So if I take x equals square root of t plus 2 and subtract the 2 from both sides, I have x minus 2 equals square root of t. Then if I square both sides, I'd have x minus 2 squared equals t, so that this amount can go in place of the t there. And that's going to give us y equals log of x minus 2 squared. That's it. Right, like that. There's a part of me that's tempted to bring the power out front and make it y equals 2 times log of x minus 2. But they're equivalent answers, either one of those. Okay, that's it for this video.